In this video, we're going to talk about solving equations that involve absolute value. I have 5 examples for us, and we'll step up in difficulty as we go on. Before we start this first example, I just want to remind us all what absolute value is. Okay, so remember absolute value. So say for example, I were to ask you, what's the absolute value of -3? Okay, so what is it that I'm asking you? So if I were to draw a number line, here's 0, 1, 2, 3, here is -3. If I ask you what's the absolute value of -3, what I'm asking you is, how far is -3 from 0? What is the distance between -3 and 0? Well, the distance is 3. Okay, so that's what absolute value means. It's the distance between -3 and 0. It's the distance between the number that's inside the absolute value and 0. Okay, with this in mind, let's go ahead and get started. Starting here, we have, so I can draw this on a number line. We have 0, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so there's, or -4 actually. So there's this distance, this absolute value of 7 minus x. Okay, the distance that this is from 0 is 4. Okay, so just like how here, where the distance that this is -3 is from 0 is 3, the distance that this 7 minus x, the distance that this is from 0 is 4. So that means that 7 minus x either equals -4, okay, in the case that this is the distance, so this distance is 7 minus x, okay, or 7 minus x equals +4, okay? So there's 2 different possibilities. 7 minus x equals +4, or 7 minus x equals -4. Alright, so then from there, I just solve for x. So in the first one, I would subtract 7 from both sides to solve for x. So I get -x equals -4 minus 7, which is -11. And then divide both sides by 1, or -1, and I get x equals 11. Okay, so that's one possible solution, is that x equals 11. Over here, subtract x from both sides, get -x equals -3, or x equals 3. Okay, so there's the other solution. So my solution set is 3, 11. Okay. Alright, so let's step this up a little bit. The main difference between this example and the previous example is that here we need to first isolate the absolute value. Okay, so the first step in all absolute value questions is to make sure that you've isolated the absolute value, meaning this cannot be there on this side of the equation. So 4 must be moved over to the other side. So I'm going to subtract 4 from both sides. These cancel. So I'll be left with 4 minus x equals 3 minus 4, which is -1. Alright, so now this is exactly the same situation as before. Oh, actually it's a little different, because this is saying that the distance that this is from 0 is -1. But that can't be, right? Distances are never negative. The absolute value of something is never a negative number. So, no solution. There is no x that will satisfy this equation. Alright, moving on to the next example. Let's see here. Now, this one is, we know now, we're good. We know the first step in solving equations with absolute value is to isolate the absolute value sign on one side of the equation. Okay, so I'm going to subtract 5 from both sides. I know this is the first place to start. Okay, equals -2. Alright, now, when I say isolate, we also need to make sure that the sign in front of the absolute value is positive. Okay, so I'm going to divide both sides by -1 so that my sign is positive. So I get x minus 4 equals 2. All right. So unlike the previous example where, it was the absolute value equals some negative number, now we have the absolute value equals some positive number. So this is very similar to the first example, example A at this point. Okay, so the distance, here's 0, 1, 2, 1, 2, negative 2, negative 1. So the distance is 2, okay? And the equation is x minus 4, x minus 4. So x minus 4 either equals negative 2 or x minus 4 equals positive 2. Okay, because the distance is 2. Distance from 0 is 2. So I'm going to add 4 to both sides of the equation. We get negative 2 plus 4 is 2. Okay, add 4 over here. We get x equals 2 plus 4, which is 6. So those are my two possible answers. So I got 2 and 6. That's my solution set. Okay, moving on to a new example. This one is different in that it has the absolute value on both sides of the equation. Okay, so we're not able to isolate the absolute value. Well, it is already isolated. This one is already isolated, you could say, and then this one is already isolated. Okay, there's nothing outside of the absolute value, which is important. Okay, so let's see. How are we going to go about doing this one? So if we were to draw a number line, and then starting at 0, on the left-hand side of the equality, we're saying that we're going to go a distance of x plus 3, or a distance of x plus 3, okay, from 0, and then we're going to reach either negative 2x minus 5, the negative version of what's on the right-hand side, or the positive version, 2x minus 5. Okay. Now, in a previous example, we had something where, we had an absolute value, and then on the right-hand side we had a negative number. We're not going to need to be concerned about this in this or we're not going to have to be concerned about that sort of thing happening here because, they're both absolute value, okay? So on this side of the equation, you're going to end up with having a positive number. And then on this side of the equation, you're also going to have a positive number because they both are the absolute value, okay? All right, so let's go ahead and solve this. So let's say x plus 3 is going to equal 2x minus 5, or x plus 3 is going to equal negative 2x minus 5. Be careful that you put parentheses, so it's negative of the whole, 2x minus 5. Okay, so now I need to isolate x and solve. So the way I'm going to do that is I'm going to bring like terms together. So I'm going to subtract 2x from both sides. So I'll have, let's see, x minus 2x is negative x, right? And then plus 3 equals, well, this cancels, negative 5, minus 3 from both sides, negative x equals negative 6, not 6, 8, right? And then divide both sides by negative 1, and you get x equals 8. All right. Now let's do the next one. First thing I'm going to do is distribute this negative sign. So I have negative 2x plus 5. And here's a 3. Okay, x plus 3. All right, I'm going to bring the 2x over by adding 2x to both sides. I'm also going to subtract 3 from both sides. Okay, so x plus 2x is 3x. This cancels. And this cancels. And then 5 minus 3 is 5 minus 3 is 2. So x equals 2 divided by 3. Divide both sides by 3. Okay, so there's my solution set. Oops, you should always write the smaller number first. So let me just cross that out. You should always write the smaller number first. So 2 over 3, and then 8. So that's your solution. All right, moving on to the last example. this one is the most difficult because, so unlike the previous one where we had an absolute value on the right hand side in addition to having it on the left hand side, this one we don't have that. Okay, but we still have the variable x over here. So that's where it causes, a little bit of, we need to actually think about this one. Because we need for this side to always be positive, right? The absolute value of something is always going to be positive. Now, previously, if this turned out to be a negative constant, we would say, oh, there's no solution, right? So we need this to be positive. So we need for let me go ahead and write this. We need for 2x to be greater than 0. Alright, so at the end, so I'm going to go ahead and find some values of x, and at the end I need to check that this criteria was met. Alright, so just as like the previous examples, this distance is x minus 3. This distance is x minus 3, distance from 0, and then we have negative 2x over here and positive 2x over here. So when I go to solve, I'm going to have x minus 3 equals 2x, and x minus 3 equals negative 2x. Okay, so I'm going to solve. I'm going to subtract 2x from both sides. And so I'll end up with having negative 1x minus 3. This cancels, so I have 0. Add 3 to both sides, so I have negative 1x equals 3. If I add 3 to both sides. And then divide both sides by negative 1. I get x equals negative 3. Okay, now let's do the same thing for the other one. So I'm going to add 3 to both sides first. So I'll have x equals negative 2x plus 3. I'm going to add 2x to both sides. Okay, so I'll end up having 3x equals 3. Divide both sides by 3. I get x equals 1. So there's my solution, negative 3 and 1. No, right? I need to check this criteria, right? I need to check the criteria up top. So if I were to plug in x equals 3, is 2x greater than 0? No, it's not, right? So that is not a solution, right? If you were to plug in x equals 3, what would happen? You would have negative 3 minus 3, okay, equals negative 2, equals 2 times negative 3, which is negative 6. 3 minus 3 is negative 6. So you get the absolute value of negative 6 equals negative 6. But the absolute value of negative 6 is 6. So 6 equals negative 6. That is not true. Okay? Alright, check the criteria for this one. 2 times 1 is greater than 0. True. Okay? And you can double check. You can see that if you were to plug in 1, you would have 1. If we were to plug in 1, we would have 1 minus 3. The absolute value of that equals 2 times 1. 1 minus 3 is negative 2. The absolute value of negative 2 is 2. 2 equals 2. Okay, so you have a valid answer, okay? You didn't have to actually go through these checks. It's good to do that, but really you just need to check this criteria is met. That the side without the absolute value, if you check that that is greater than 0, then you should have a valid answer. Okay, so there's my solution set, 1.